Now that we have a numerical version of the time for making our graphs, we can start thinking about how we're going to go about plotting the 72,000 observations that we have. We're pretty used to thinking about time on the scale in a matter of weeks, right? 7 days at a time. So maybe that's a good way of thinking about making these graphs 7 days at a time. Ultimately, that sounds like a job for a loop or some sort of algorithm where we're going to loop through some sort of logic that takes this data 1 week at a time and makes a plot. But before you start working on a loop, I think it usually makes sense to write the code that does what you want the loop to do once, make sure that works, and then you can go back and you start working on the loop and putting the loop code around that. So let's get a really simple version of this working, and we can add complexity one step at a time. So first of all, after we've designed our time, we need to set up a graphics device. Now we could use the default graphics device in R Markdown, and that would create a graph directly in this report. But this is going to be a pretty hefty number of graphs. We're talking about several weeks or many, many weeks over a whole collection of 3 seasons. That's a lot of data, and maybe that's a little bit too much to put directly in this report. And we'd rather just have a PDF file with a book of graphs that we can pore over as we try to make sure the data look good. So instead of using the default device in R Markdown and making a graph in the report, let's just go ahead and make a graph in a PDF file using one of the PDF devices. The PDF device I prefer is Cairo PDF. Just gives you a little bit more flexibility in what you can do in creating a PDF. And we need to give a file name argument. And let's just go ahead and define a path separately up here, because maybe in our report, we ultimately want to send out to the report the fact that we've generated a graph in a separate file. So I'm going to define the path separately up here. This is going to go in our for_product directory, because ultimately this graph should be part of the product. This should be something that another user of the data might want to quickly open up to scan the data to make sure it's what they're looking for. So let's put this in the products, because ultimately this will be part of the data product. And for now, let's just call it visualization.pdf. So that's the path of the file. We've defined path as a separate variable, define this as a character string for that path, and we assign that path to the argument file name for Cairo PDF. The other thing we need to tell Cairo PDF is, well, what's the size of each graph or each page of this PDF we're going to create? I'm just going to pick 8 by 6. That's a pretty good aspect ratio for a lot of graphs, or for many graphs, I should say. So each page of our PDF, that's ultimately going to be several pages with a graph on each page, will be 8 inches wide by 6 inches high. And for a file-based graphics device, we need to make sure that at the end of all of this, we turn the device off, because the file that we're creating won't actually be created until we do a device.off. So we can make sure that this works. I think this is enough code to run. So I'm going to go ahead and run this chunk as it is. Note that we have a relative path here. So this is only going to work if we have our init directory set up for the correct working directory. So yes, we're using the current working directory, so this should work. If I run this chunk, I'm getting an error. Error while writing to output stream. So it can't write the file for some reason. Now we're not getting a pretty good specific reason why, but ultimately it can't write. And in this case, it's because we're using a path that doesn't exist. So we have for_product here as the subdirectory of our working directory where we want to put our visualization, and we haven't created that directory yet. So let's create a new folder in our pipeline. Call it for_product. And let's give this another try. Okay, now it runs without errors. And if we look under product, we have a visualization.pdf file. And if I open that up, it's just going to be a blank page because I haven't actually done anything yet. So I've created a canvas. This is one 8 by 6 inch canvas, but I haven't put anything on it, so it's just blank. So I'm going to leave that on because with the Sumatra viewer, I can just refresh it if I update it. One thing that's happening here, notice that when I ran this chunk in RStudio, I get this output here that says null device 1. Now the reason I'm seeing that is because the dev.off function actually returns something. It returns a string, and this is the string it returns. Now if I'm seeing this here in this little screen in RStudio, that means whatever comes back from dev.off is going to end up being written to my report. Because remember, by default, I have my chunks sending whatever string or whatever character strings are generated by the chunk and putting it right back into the report as is. And we don't really want this going to the report. So there's several things we could do. We could either assign a variable here so that it's what's being returned by dev.off will be assigned to a variable instead of being sent to standard out and showing up here. And that should work. See how it no longer shows up? Or there's another function that will let us do this without having to assign another variable. And the function is invisible. If I call dev.off within the function invisible, that also will prevent whatever is returned by dev.off from showing up in our report. So a couple of different ways to handle that. We could also change the chunk options for this chunk to not send anything, but then we wouldn't be able to send anything else from this chunk, which we might want to in the future. So I'm going to use this option right now. So now we have our device set up. Let's go ahead and think about the time range that we want to graph for our first graph. Let's define a week start variable that's going to say what's the beginning of the time that we want to use for making a graph here. And let's just go ahead and say, well, let's just start with our starting time from the time that we just created here as a column in our data table or our data frame. So I can do table $time here. And also by reflex, I usually set the na.rm argument whenever I'm doing a min to true, just because I typically want it to ignore NAs. Now in this case, I'm pretty sure there aren't any NAs, but this is just something I tend to throw in there because by default, na.rm is false, which means the function will return an NA if there are any NA values in the data. And I'll have another variable here that I call week end, and I'm just going to base that on week start plus some amount of time. Now, once you have a numeric representation of time, you can start calculating other intervals of time based on the fact that it's storing time as the number of seconds since some epoch, in this case, January 1st, 1970. So if I want week end to be 1 week later than week start, I can add however many seconds there are in a week. And I can calculate that as 7 times 86,400. I do a lot of modeling, so I just happen to know there are 86,400 seconds in a day. I could also calculate this number down here in the console, just type 7 times 86,400, and I could get this number 604,800 and just put it in place, just so my program isn't having to do that math every time it runs. So week end is going to be week start plus 60,480, or 604,800. So let's run this chunk and see what we've got. If we've got a week start, that's going to be our first time, and we've pretty much established now that's on March 4th at 12:30 in the morning. Again, this is UTC time. And our week end is going to show up as March 11th at 12:30 in the morning. So we have added 1 week's worth of seconds. That means we're still in the POSIX CT type. And when we look at that week end that we've just calculated, it'll show it to us as a date time, and it is indeed 1 week later. All right, the next step is to figure out which data we want to put in this plot. So we need to filter our data based on this week start and this week end. That means we need to come up with indices of the data that we want to plot. And we can do this with logical operators. So we want all of the table $time indices that are greater than or equal to week start. And then we can use logical operators here and all of the times that are less than or equal to the week underscore end. So what this operator is doing is letting us say we need two conditions to be true for an indice to be true. We need table time to be greater than our starting time, and we need our table time to be less than our ending time for this particular plot. And then I can run this. I'm going to do a which on indices. And there's actually too many indices to see all of them. But this is going to represent all of the indices that are this week of data. And we will be able to see this work when we actually make a plot. So that means we have the indices that represent just the week of the data that we want to plot. Now we need to filter our data. I'm going to go ahead and create variables just so it's easy to read the code. So I want all of the times that are at these indices that represent the times that we want. And I'm going to call that a vector of times called week time. And then our week par, same idea. I'm filtering out a vector of values that are just the week of par values that we want to put in this plot. So now we're almost to the point where we can go ahead and do a simple plot of this just to make sure it's working. Again, my recommendation is think of the simplest version of what you want to do with code, get that working, and then add complexity one step at a time. And that really helps with debugging because when you encounter a problem, you know exactly what caused that problem by doing things just a little bit at a time or adding complexity one step at a time. So I'm just going to use the simple plot function for now. Make a quick plot of week underscore time is my x variable, and week underscore par as my y variable. And this should be the simplest version I can think of to get a plot going and help me think about how I want that plot to look and how I want to start working as we move on. So let's go ahead and we can run this chunk. In this case, I'm just going to Control-Shift-Enter, run the whole chunk, go back to our PDF file, and it's automatically refreshed. So we can now see we have a simple plot. Our labels on the plot axes are going to just be the same thing as the variables because we haven't told it anything else. So it's our week par variable versus our week time variable. R has made some guesses at how we want to scale this based on the data we've given it. And we can see that we have dates and we have ticks every 2 days. So there's March 5th, halfway in between would be March 6th, March 7th, etc., etc. And we have our par measurements here scaled according to the minimum and maximum values for this particular week's worth of time. So that gets us to the point where we have a simple graph and we can start thinking about how we want to make this graph look better and more effective for our purposes in terms of doing quality assurance on the data.